Before we make a start on solving all the 10 questions, firstly, scroll down. If you'd like to have a go at the questions yourself and you can't find the PDF on my website, well, I've linked it down below. So open it up, print it off, have a go at a few before I show you all the ways and whys of going about things. And let's give you a few hints or tips that might just help you in the right direction. The first thing is, because these are the more meaty questions, the multi-layered questions, you might need to do Pythagoras followed by SOHCAHTOA. If a question asks for the answer to one decimal place, work in at least two. And that goes on and on through significant figures as well. If you aren't a fan of how they explain, how do I find the angle between a line and a plane, can I remind you that if that's the distance A to F or whatever, and they want the angle between A to F and a plane, in other words, a flat floor in most cases, think of it as shining a torch from the plan view from a helicopter. The shadow it would cast would be there, and that's the angle you're going to be after. Which brings me to my third hint. Redraw the shape off the diagram. It shows you the right angles much better, and you can just repeat the labels. Your redrawings, they don't have to be accurate, they don't even have to be good. They just need to show you clearly which bit of SOHCAHTOA you're going to need to use. And on that note, even though it's 3D trig, in other words, quite tough trig, although SOHCAHTOA is your go-to, sine rule and cosine rule do crop up. But I'd say 9 times out of 10, it's Pythagoras or it's SOHCAHTOA. They are much more likely than the other two. And also, because in any question, you're normally dealing with the line across a shape, which will be required to use Pythagoras, and the vertical, it's much more likely that you'll be dealing with opposite and adjacents than any of the others. So not only are these 4 little bits more important than sine rule, cosine rule, it's actually Pythagoras and TOA that will be your default options. Use them unless you've got a good reason not to. But anyway, time to shut up. Let's get on with the questions. So as I'll be recommending with each and every one of these questions, always have a read of the question to make sure there's no extra information in there that's not already on the diagram. Let's do it first. As you can see, AF equals 10. Got that. AB 24, yep. BC equals 8. They're all done. They've just repeated information. Those angles are all 90 degrees. They're basically just telling us what, again, we already know. So just waffle. Just designed to put you off and stop you from accessing the question. Don't let it. Again, as with all of these questions, it's identifying what you're trying to work out as being probably the most important part of the question. Work out the size of the angle between the line BE, in this case they've actually drawn it on, and the plane, the flat surface ABCD, or in other words, the floor. Now, if you are the sort of person who's never sure where to draw your line, think about if there was a light shining from above, looking at the plan view, where would the line BE cast its shadow? Its shadow would be cast there. That's the key step. That's your triangle, your right angle triangle. As we'll be saying on a lot of these videos, this might not look like a right angle, But it is, because otherwise how on earth is ED a vertical line? Because we've been told that FA is, and therefore that is as well. So it has to be. It just doesn't look like 90 because of perspective. But what will help you out is if you make a drawing of this triangle. Doesn't have to be any accurate information required, nothing worth measuring, not even worth using a ruler. I'm just doing it to fill time while I waffle. So we've got E down to D. That's the vertical line, which is corresponding to AF, making it 10. We have the line D to B, which we do not know. Be nice if we did. We'll come back to that, but that's the plane line there, the DB. So the angle you are attempting to find, let's stick an X on it. Now you could go with, while you want to try and find the line EB, nah, not worth it. Let's look at the floor. The floor is a rectangle. If we pick on this half of the rectangular floor, again, it might not look like it, but it's right angled. And D to B is the hypotenuse of that right angled triangle. Now you could draw that, but I would argue it's less important to draw for Pythagoras, particularly once you know where the hypotenuse is, than it is to draw for a triangle here, where you're not sure if it's sock, cat or toa. So for here, we want the hypotenuse. That line there is DB. If we knew that, off we go with SOHCAHTOA. How do we find it? Well, great news. We know that that shortest side is 8. That other shorter side is 24. You don't need to write out a squared plus b squared. Absolute nonsense. We know we want the hypotenuse. We are going to square them and add them and square root the answer. If it's an older calculator, you'll have a decimal. If it's one of the more up-to-date ones, you'll get the answer as a surd. That's absolutely fine. Don't clear it from your calc. If you know how to use the A&S button, keep it in your screen, saves you retyping. Now we can move on to find X, and ultimately you've taken a tough question and you've now reduced it to a normal-looking, bog-standard SOHCAHTOA. That's the hypotenuse. We're not interested. It's only the O and the A which we know. It's a TOA. You're after the angle. Circle the T for tan of the angle. So to find it, whenever you want an angle, its inverse, shift or second function, and its opposite over adjacent. 10 divided by 8 root 10. Your calculator hopefully agrees with mine. 21.56-ish. Don't forget to always double check the question. 21.6. And I'd also argue double check. Does 21.6 seem reasonable in terms of it, as long as it's not something close to sort of 80, that would be unreasonable, because even though a diagram is not accurately drawn, it can't be drawn to be stupid or misleading or anything like that. So I'd argue that 20 or 30, in that ballpark, makes absolute perfect sense. So on this second question, the first thing that will probably be drawn to your mind, apart from the M's and the midpoints, there's no numbers. At the end of the day, you can do whatever the heck you want. When you've got questions, and whether it's percentages and you don't know the start, you can always refer to that initial as, let's say, 100%, or in a ratio question where everything's in the same proportion, you could call the first person 10. You could call them X. Now I'm going to do this question in terms of x, but just to illustrate, there'd be nothing stopping you on this question from having a side length of 10 and getting on with it and calling g to m 5 and cracking on from there. Nothing stopping you. Feel free to try it. It will work out. But to prove it'll work, I'll do it for every possible number. In other words, x. But like all these questions, first thing to do is have a look at where are you looking at? Where's that triangle that we're trying to find? Find the size of the angle between MA, get them joined up, and the plane ABCD. So again, that's the floor. Think of yourself as looking from above, shining a torch down. The shadow that would be cast would be along that line there. Obviously, you are free to call the sides any letters you want if you want, but I'm going to stick to the side length being 2x. So the distance between B and, I'll call it N, that's going to be an x. There is our right angle triangle. So ultimately, that's what we are aiming to work with. It's this triangle. And again, you don't have to draw these accurately. You don't need a ruler. You just need something to give yourself a focus, because ultimately it will all boil down to the correct selection of soccer toa. And don't forget, it's usually toa, but let's not always make that assumption. The angle we are looking at, I've already used x, so let's call it y. And it runs from A to N. N is where the right angle is, and N runs vertically to M. And we don't know A to N, we don't know A to M, but we do know that that is 2x. And there's the logic that's required in these questions. We could do with either that side or that side. Either will suffice. Which one's best? Well, always think about looking down from above. I didn't do it on the previous question, but I'll do it on this one. If you look at this cube from the plan view, the perspective of straight above, you'll see that going from A to B, that's 2x. Going from B to N, that's x. It is possible to work out this side A to N. On the first triangle, it's the hypotenuse. There's no angles apart from the right angle. We can use trigonometry. We can use Pythagoras. The longest side is the square root. You square that side, you get x squared. Square this side, 2x multiplied by 2x is 4x squared. And just to simplify that slightly, the root of 5 is the root of 5, or the decimal equivalent. The root of x squared is x. But you can call it the decimal, the 2 point whatever you want. I'll not bother. That's x root 5. That can slot on to that diagram down here. And as I said, they're usually toa. This is that case because the hypotenuse, A to M, not involved. We've got the opposite to y, the adjacent to y. It's another toa. We want the angle. And before people start thinking there's x's, trust the process, keep it going. Usually, unless you've made a mistake, usually these letters cancel out. To get the angle, it's inverse tan and its opposite, which is 2x, divided by the adjacent, which is x root 5. But on your calculator, the x's cancel. You'll need to be second function, shift tan, whatever your button on your calc gives you the tan to the minus 1 of 2 over root 5. Hopefully you get 41.81 and so on. Do as you're told if you are told something. 1 decimal place. So 41.8 it is. I really need to practice my 8s. This third question of these set is very similar to the previous one in that you haven't got any specific numbers, but you have been given a relationship between the three. Now, the easiest way is to call them 4, 2, and 3. If you call them 4x, 2x, 3x, it'll still work. The x's will cancel in a very similar way to the previous question, but it just makes the Pythagoras step slightly more tricky. So I'm going to avoid that this time. You could call it anything you wanted to. If you called that 10, as long as B to C is half that, it's fine. As long as C to F is double and that, sorry, not double, add on half to get 7.5, it would all work out in the end. Feel free to try it. It's entirely up to you, but I'll stick with what we're told. Next stage is always identify what you're trying to find. It's A to F and the plane, which yet again is the floor. So draw on the shadow that it would cast if a torch was being shone from above. The angle that we're being asked to find is between these two. And I'm a massive advocate of saying to you, always looks a bit easier. SOHCAHTOA just looks that bit more doable. It's part of the reason why they give you all that room when you don't need all that room. They're just saying, look, if you want to draw a diagram or two, go for it. So there's our angle X going from A across to C, C up to F, we actually already know. And although you could try and find A to F, that'd be workable, bit of 3D Pythagoras, I'm going to stick to working out A to C, because that's a bit of 2-dimensional Pythagoras. A to C is the hypotenuse of the floor. We're going to square the 2 and the 4, add them together to get 20, and square root it. You're more than welcome to write it as 2 root 5. I'm not going to bother. But now we're done. All the 3D stuff is done. It's now back to 2-dimensional. Opposite and adjacent. Hypotenuse is useless. It's another TOA. We want an angle. Hit that second function, inverse shift, whatever it is on your calc. And don't forget to close the brackets, by the way, so it's 3 over the root 20 or 2 root 5. Don't forget to close your brackets. Do make sure you get the same answer as me. 33.85. We're told to go for 1 decimal place, so 33.9 it is. Question 4, bit more meat on this bone than the first 3. This one's a 6 marker, so definitely going to need 3 stages of working out for that. Also, more waffle and more numbers involved, and even a bit of surface area, but let's not let that put us off. What are we told? Top line tells us nothing we didn't already know from the diagram. First thing is the base. It's 10 by 10. It's a square base. Vertex is vertically above, we know that, and all the side. That makes it all the same. Yeah, whatever. It's basically telling us the 4 triangles around are the same size. The total surface area of the pyramid is 360. Let's stop. Let's not go ahead with all the trigonometry. Let's get on with that. Now, the line I'm putting in is the height of the triangle on the right-hand side. You could put it on the front one, but I'm going to put it in on this one. Why is that important? Because that is the height of the triangle. If you're going to apply logic, the surface area is the area of the base, which is 10 times 10. So let's take that away. The area of the four triangles must equal 260. So let's do that sum. There are four triangles. The formula for the area of these types of triangles, just do half base times height, but the height is not AO. The height is this slant. I'm going to call it Y. The base is 10, so a half of the base multiplied by the height gives us 260. We know that Y is 13. That's going to help. That's that bit done. I'm going to stop crossing it out because I might need it again. Work out the size of the angle between A to C. So now let's get that on. Different colour. A to C is that ridge there. Bit off wonky, but who cares? This is why I don't do technology. If you ever watched any of my other videos, there it is. I'm a big fan. Flipping heck. I'm a big fan of redrawing them. Doesn't matter if it's neat, accurate or whatever. No one cares. What do we know? Well, AOC is what we're working with. They want us to find that. That's the angle at C. What do we know? Not a lot, unfortunately. We know it's right-angled. Y doesn't have any bearing on this directly. We're going to need to do a bit more thinking. So, A down to here, along to here, and up to A, that's a right-angled triangle. Y, as we've worked out, is 13. C to halfway is 5. We can work out A to C by applying Pythagoras to this blue triangle. On this blue triangle, AC, as you can see, is the hypotenuse. A to C means we need to square and add, and then square root. 169 plus 25 is 194. You could use a decimal equivalent, but I'll stick to that. One side. Great. How can we find one of the other sides? Now, you could use Pythagoras to go for AO. That would work. But I'm going to now focus on this little distance, O to C. Because as you can see down here, that'll be another right angle because this is nothing more than a 5 by 5 square. A 5 by 5 square will have a hypotenuse of 5 squared plus 5 squared, which is the square root of 50. Just squeeze it in down there. Now, I've mentioned both on my introduction and throughout the previous few questions, 9 times out of 10 or something like that, it's TOA. This is one of those 1 out of 10 where it isn't. This one isn't TOA because, as you can see, redrawing it, the angle we're after is there. That's the hypotenuse. Opposite is useless. Adjacent is there. It's A and H. It's a K. We want the angle. It's our usual second function, inverse or shift, whatever button you've got. Press it, followed by cos. And it's adjacent divided by hypotenuse, giving us 59.49 and so on. 3 sig figs was asked for, so 59.5, and that's why that was a 6 marker. So a much more standard type of question for this one. You're given all the numbers. There's no real waffle. It's a cuboid. Just draw the triangle where you're trying to work stuff out. Work out the size of the angle between A to H. Get it drawn. The shadow that would cast, shining a torch from above, would be F to H. And there's the triangle. Not too bad actually, but I'm still going to stick with it's just easier, in my opinion, if you take it off the diagram. Just shows you that right angle that little bit clearer. We've got A on top down to F, which we know is 6. We've got F to H, unknown, but can work it out, the angle we're after. And we could, the longer way of doing this question is to find AH. That would require 3D Pythagoras. Feel free to get on with that. Just square rooting 9 squared plus 5 squared plus 6 squared. It's not that hard. But I'm going to stick with Pythagoras on the floor, because this distance F to H is the hypotenuse of a 9 by 5 rectangle. 9 squared plus 5 squared square rooted gives us the square root of 106, or the decimal equivalent. But now we've got it onto 2 dimensions. Is it Soka? No, it's usually Toa. Not always, as you saw in the previous one. We're back to normality here. So to find our angle, inverse tan, because it's the opposite, which is 6 that we know, and the adjacent, which is root. Come on, Al. Root 106 that we know. 30.23, etc. 3 sig figs is what we're told. Always do what you're told. Number 21 ramps it up to a 6 marker, so as soon as you see 6 marks for 3D trig, you know it's going to be at least 3 stages of working out. This is no exception. Let's have a read through, let's see, because as you can see from your diagram, there's no numbers on it. You need to sort of sift through the information you're given and get all the key information on there, ruler at the ready, if you want to put any of that on. Angle BEC is 40 degrees. Let's draw the line, because BE is already on, CE is not. So the first thing on goes, that is 40. It doesn't look like it, but that CBED is just a rectangle. Looks like a parallelogram because of perspective. It's a rectangle. So you need to put a bit of a note in there that if you need to, this is just a SOHCAHTOA question. A to C to B is obtuse. So this is important. Let's call it an X, and let's remind ourselves it's obtuse. A to C is 6. On it goes. Very tempting to put CB as 6. No, you're not told it's isosceles or anything like that. Just because it looks like it doesn't mean it is. What else goes on? C to E is 13. On it goes. And the area of ABC is 22 centimetres squared, which obviously is going to come into play at some point. What I would say is calculate the length of AB. That's that distance across there. If you look at the triangle ABC, there's no way you can use SOHCAHTOA on that, unfortunately, because X and the angles at A and B, I know they certainly don't look right angled. Not drawn accurate, but they just aren't, are they? Let's be honest. All right, so you can definitely check that final stage involving those, we're going to need a sine rule, cosine rule situation going on. Let's get our x in there. That's 6. We've got A, B and C. We're going to need more information because although we know the area of this is 22, not enough. If you know the area of a non-right angled triangle, you also can think about half AB sine C, etc. But we only know one of the sides. How can we find another one of the sides? Look at that triangle where they've given us plenty of information. Again, let's take a bit of time, always worth it. Let's redraw it. Let's have a look at that in more detail. So C is at the top, C down to B. Wherever that is there, that's what that is there. Definitely worth looking at. The 13 is the hypotenuse, and as I've mentioned, that's a right angle. That's also 40. So bags of information. Let's find C to B. Hypotenuse, opposite, adjacent is useless. This one is a saw. I'm squeezing it up here because I know I'm going to need plenty of room. I want the opposite, which is C to B, and that means they are multiplied. It's sine 40. If you've got one of them calcs that opens brackets, make sure you close it. Multiplied by, what have we got? 13. That gives us 8.356-ish. It wants the answer to one decimal place, so I always say to people, you should work in 2 or 3. So I'm going to use 3. That question mark can disappear now. We know what it is. And now we can bring into play this 22. The area of ACB, 22, is a half times one of the sides times by the other side times by the sine of the angle between them. We're going to need to inverse sine something. That something is 22 and just do opposites. Times by 2, divide by 6, divide by 8.356. I got 0.8782-ish, which means the angle is 61.4. Or is it? Let's not forget a little bit of knowledge. I'll go up here. I know one thing about 61. It's not obtuse. But have a refresher course on your sine curve. Two angles between 0 and 180 have the same sine. You'll know that the sine of 30 is a half, but so is the sine of 150. That's also a half. How do you find the second angle? Take this away from 180. So we can't say that's what x is. We can say that the x we're interested in is 180 minus 61.4, 118.6. That's definitely obtuse, and now we can finish off the final stage. You've got this angle, 118.6. You've got the two sides adjacent. You want the opposite. It's cosine rule. So the cosine rule says that the opposite side squared is equal to the other two sides squared and added minus 2 times the product of these sides times by the cos of the angle between them. Be careful with your brackets. You might have another smart aleck calculator. At the end of the day, sticking all that in your calc, you should be getting 153-ish. And when you square root it, don't forget, because that's the formula for a squared equals b squared plus, or however, whatever form you've considered it to be in, it needs to come down because it's 12.40, and that's one decimal place. The seventh question, a strange shape, but they've broken it down, so they've kind of made it a bit more digestible, but still, the second part, not as straightforward as the first. Again, lots of information. Is there anything that they've written that's not marked on the diagram? Diagram shows there's nothing up there. Base of the prism is a square, that's told by nothing down there. Trapezium is a cross section, vertical edges, nothing down there. And the 10 and the 15, they're already marked on. So it also tells us A to D and D to C if we need them. Straight in, work out the size. Let's get our ruler. CF and the base. CF is there. As always, the shadow it would cast. And CH, well worth redrawing, helps you picture it for me. And now let's add on some labels. So from F, that's the angle we're being asked for. The opposite side, C to H, that's 10, we know that. What we'd like to know is either F to C or F to H. Well, as usual, whenever you've got the base, you've usually got the measurements, and looking down on it, F to H is the hypotenuse of a right angled triangle. Let's crack on. 12 squared plus 12 squared square rooted is 288 for F to H. Your calc will simplify that to 12 root 2. And there we go. From your angle, you've got your opposite, you've got your adjacent. It's yet another TOA question. So it's the inverse tan of the opposite divided by the adjacent. And one decimal place. Calc says 30.508. 30.5. And now the slightly trickier part B. Work out the length of BE. Now BE is the diagonal opposite from there through to there. It'd be a nice straightforward 3D Pythagoras question if we knew the distance from G to B. We don't. We know part of it. We know some of the distance from B to G, and I'll draw it on A to F because it's the same thing. We know part of it is 10. What we'd like to know is the rest of it. There's this extra bit up there. So how can we find that? Well, the good news is we know the distance from A to D. That's 15. And that's the hypotenuse. We know the distance there to D. That's 12. Yep, it's Pythagoras again. 15 squared minus 12 squared all ends up giving us 9. So we've got the distance from A to F, in other words, B to G. That whole distance is 19. Therefore, doesn't matter that it's a trapezium, because when you want to do three-dimensional Pythagoras from one corner to another, you just need to apply standard Pythagoras, that you need to add the 3 dimensions squared and added. That 19 comes in very helpful. Gives me 25.47, which is 25.5 to 1 decimal place. Question 8 or 18 if you're looking at that one. Bit more standard looking, but brings in the extra bit of volume. We've had a surface area question earlier on with the pyramid. We now got volume. What does logic tell us? To work out the volume, you need the 3 dimensions. So in other words, we are needing the distance B to C or something thereof. Let's have a read of the question. Are we told anything new? Not there, we're not. Not there, we're not. Not there, but here we are told that the size of the angle between C to H, let's get it drawn, and the plane, which yet again is the floor. So let's draw the shadow that it casts down there. That's our triangle, well worth a redraw, particularly if Sokotoa has a habit of letting you down. I know it doesn't meet, no one cares. Doesn't have to be good or accurate, as long as my labels are good, that's 4. There's C, that's where the angle is 35. And if we're to work out anything about, because we're wanting the distance B to C, haven't got it yet, but obviously from the 4, usually the diagonal of the floor is the most important thing to find. It will be, because we'll use it in Pythagoras to do hypotenuse squared minus 5 squared to give us BC squared. But let's track this bit first. Opposite is 4. Adjacent is required. It's a TOA question. And our x is going to be 4 divided by the tan of 35. Now it's asking for 3 significant figures. You should work in at least 4, or if not 5. We've got the 5.712 running from A to C. Looking from a plan view, looking downwards, it's right angled. Now we can make the statement that BC, which is the distance we want, it will be the hypotenuse squared minus the smaller side squared into your calcs, 2.7629-ish. But you haven't finished, because that is the distance B to C. We're asked for the volume, one more step to go. Take your 2.76 odd, don't clear your calculator, should still be in there. Your job now is to multiply it by the other 2 dimensions and give your answer to 3 significant figures. So 55.25, etc. becomes 55.3. Hopefully your 5s are better than mine. For our penultimate question on this revision, we've got a very, very waffly and a non-standard trapezoidal prism, also not standard. Let's go through what we might need to add to the diagram. Nothing up there. It tells us which are parallel. We can add those lines on if we want. The base AD doesn't tell us anything new. They're rectangles, nothing new. Midpoint of BC is vertically above the midpoint. Now what that does tell us is that this is not only a trapezium, it's what's called an isosceles trapezium. In other words, that's a line of symmetry. But what's more important is the triangles on either side over here, they are equal. So you're left with a rectangle in the middle and it balances up with a right angled triangle either side. On next, they give us some data, but all that's on the graph. The perpendicular distance, in other words, the trapezium's height is 20. Work out the total surface area of the prism. Easy bits. Working out the roof, that'll just be 28 wide by 24 deep. That's easy. The base is 37 by 24. Also easy. What isn't easy is the sides, because the sides are rectangles. Now, in a rectangle, let's just stick that on there. In a rectangle, the area is the 24 multiplied by the length of C to D, or in how I've marked it here, from F to E. And that's not been given. We've been given the 20, which is there, but to find F to E, we need this little bit here. Now, to find that, we're going to use the fact it's an isosceles trapezium, because 37 minus the 28 gives us 9. So the overhang is 9. And it's the same on both sides. So that little distance there is 4.5. So we actually do have the distance from F to E if we use a bit of Pythagoras. F to E is the hypotenuse, so we need to be square rooting the 20 squared added to the 4.5 squared, and we get actually quite a nice 20.5. So now we can easily work out the areas of the left and the right rectangles. What we also have, by the way, is the front. Well, we've got the 28 and the 37, and therefore we've got the back. We can now jump in that the surface area, let's do it all in one go. The base, I've already said, added to the roof, I've already said, 28 by 24. And you've got two lots of the right hand side, which is the 20.5 we've found by the times by the 24, and we've also got the two trapeziums. Let's do the trapezium at the front for the example. Two lots of. How do we find the area of a trapezium? We add together the parallel sides and halve it, so they'll just cancel, multiplied by the vertical distance between them. That's our 20. And we're there. All that into your calc. Be careful with your brackets. We get 3,844. Trouble is, there's a part B. And part B says calculate the size of the angle between AF and, yes, you've guessed it, the floor. So let's pick a different colour. Let's draw the line A to F. And don't draw this over to E. That's the corner. That wouldn't make a triangle, or a right angled triangle anyway. It'd make a triangle with a bit of a gap, but you don't want to bring FE into play as the third side of the triangle. The angle we're being asked for is that angle there. So we actually know that the opposite side is 20. We just need one of the other two sides. As I always recommend, let's make a sketch and let's see where we are in the problem. Again, sketches don't need to be good, accurate, as long as you know what you're doing. That's the angle we're after. The opposite was 20. That's F. It'd be nice if we knew one of the other two sides. Let's have a little stare at the diagram. Can we find any of the other two sides? Well, let's trace that along there. This distance is 37. Okay, all the way along that distance. Sorry, 37 is all the way along to there. Just correct myself. It's 4.5 smaller than that. So 4.5 smaller means let's scribble that out because it's 32.5. Good news is that distance ready-made. It's 24. That will give us the baseline of the triangle. It's the hypotenuse, and they're the other two sides to square root. So to find this distance here, we need to square root the 24 squared added to the 32.5 squared, which gives us a horrible decimal, 40.401-ish. But we've now got enough. As happens a lot of the time, opposite, adjacent. Yep, it's inverse tan of the opposite over the adjacent. And one decimal place. Calc says 26.337. That'll be 26.3. For this final question, it's a strange looking one, I'll admit to that. Let's have a read. Is there anything in here? Well, it does look strange just to say ABC. Think of that as your flat. That's your base. You could draw it like that if it helps you picture a field a little bit better. But that's the horizontal plane, or in other words, the floor. T, think of T as like a flagpole. That's vertically above. Angle ABC, that's on the diagram. They're on the diagram. That's on the diagram. And that is just putting a bit of more information. Calculate the size of the angle between MT and the horizontal plane. As always, the shadow that would be cast if we shone a torch from above gives us this triangle here. Let's make a sketch. That's the triangle we're interested in. Let's add some information to it. M is there. That line B to there, that's that. That's the angle we're being told to find. That's that. And we've got the height of the flagpole as I've described it, up to T of 10. As always, what we don't have is a second side. We would really like to have either M to B or M to T. If you're not sure, say to yourself, what information have we been given that we haven't yet used? And it's that 140. Now, if I just change my pen seamlessly, look at this triangle in here. By being the midpoint, that's a right angle. By these two creating an isosceles triangle, that is half the 140. You could obviously use the fact that that is 20 as well if you wanted to go for the bigger triangle, but it's entirely up to you. Who cares? You've got a triangle. Let's stick the 20 on there. We know that the hypotenuse B to C is 8, and what we'd really like is B to M. because B to M is what's missing from our diagram down there. Yep, it's double SOHCAHTOA. I always say it's usually tan. This is one of those other exceptions to the rule because we'd like the opposite. We've got the hypotenuse, so this is a SO. To get the opposite, we need to do sine of our angle. Don't forget, if your calculator's a smart aleck, close the brackets before you multiply it by h. You should be getting 2.736-ish. And that's the info we require. We can take it forward, stick it on our diagram. There's the angle we want, opposite and adjacent, and yep, you've guessed it, it's another tan. I think I'm right, it's happened about 8-9 times out of 10 on this entire booklet. But let's keep going. Opposite is 10, adjacent is 2.7-ish. Answers wanted to one decimal place. Calculator says 74.69. 74.7. I've chopped it off, but it was a 4 marker. So I hope those 10 quick 10 questions have helped for your 3D trig. Again, notice sine rule and cosine rule extremely rare. Tan, TOA, most popular, SOT and CA do occasionally come up, but it's Pythagoras and SOHCAHTOA way more than it is non-right angled triangle stuff. So I hope that's helped. I will end up making another one of these 10 questions, but I'll get on to some other topics first before going full circle and coming back for some more. But I really hope that's helped. Might see you on the next revision.